Welcome to the 30th PyData Slovakia Meetup. And thank you all for coming and joining us via Zoom or in person here in Bratislava. Vrije. I will now give first word to our host from Vrije, Lukáš Čoka. He's the leader of the data science team based here. So we'll say some words.
Thanks, Radovan. I will be very fast. I would very much like to see more of you in person because we prepared lots of refreshments. But in the meantime, we are very happy to host you. Now the second time in 2 weeks, we look to collaborate more with communities that wants to bring innovations, educations, and other interesting topics to other people. So we have nice offices. And also one thing is, I should also mention, Switzerland is still growing. So in case in this hard job market, if you are looking for some options, check our website. And thanks for that. And I leave you to the good presentation.
Okay, so thank you, Lukáš. Now we will move to the first just info about how you ask questions or how you will use Slido during the event, and you can win some prizes. This from O'Reilly book and t-shirts from Nextech, and also free dev stickers from PyData are available here. So the winner will be picked by our today's speaker, Maryam Alimardani, and you can easily join via the QR code there or by adding PyData SK at slido.com. So we also thank all our partners, and now I will give word to Maryam.
So thank you for having me in this session. I think I know Radovan from a few years ago when I was invited to a conference in Bratislava and gave a talk there as well. So we have stayed in touch, and then recently he reached out and asked me to sort of give a repeated presentation of and a sort of motivational pitch that I gave for students who were thinking to pursue a PhD program in the future. At the time when they asked me to do this, I actually told them that, look, PhD can be a very rewarding experience, but I would like to also talk about all the aspects that come together with this as a package, the negative ones as well as the positive ones. And that's what this presentation is going to be about. So I would like to first introduce myself, then talk about my own research as a PhD researcher and later as a faculty member. And then at the end, I would like to share a few words about what it means to pursue a PhD program, to become a researcher or a scientist in the academic environment, and what to consider if you are really going for this. So that explains my title, Navigating the PhD Journey, Lessons Learned from My Research with Robots and Brain-Computer Interfaces. Now, one slide about me. I actually did my PhD research in Japan. At the time, I was a student that completed the bachelor's, the undergrad program, and master's program in Japan. I received a scholarship from the Japanese Ministry of Education when I was quite young, and I went there to pursue my graduate studies. And it all led to this experience with completing a PhD program and later a postdoc in Japan. So I was first at Osaka University, and there my PhD was conducted within a very famous lab called Ishiguro Lab. That's a Japanese Hiroshi Ishiguro is a Japanese roboticist that is quite famous because he created human-like robots, one of which was an exact replica of himself. And I actually use that robot in my experiments. You can see it in the image on this slide. But then later I got this fellowship from JSPS, which is a funding agency in Japan, that allowed me to continue my research in Tokyo University. And there I was again working with robots, but with a different perspective. This time, rather than focusing on Android robots, I turned into humanoid robots, social robots for therapeutic interactions. And then as of 2018, I moved from Japan to the Netherlands and I became a faculty member, first at Tilburg University and then more recently at Vrije Universiteit Amsterdam. That's the sister university of University of Amsterdam. Both universities are located in Amsterdam, the capital city of the Netherlands, and we have quite close collaborations with them. But essentially, yeah, they are two different universities. Let me tell you a bit more about what I did as a PhD researcher at the time in Japan. I got introduced to the domain of brain-computer interfacing at the time. And these are the systems that collect brain signals from a human user, enabling them to control external devices. So the selection of the neuroimaging technique can be quite diverse. You can have from implanted electrodes all the way to non-invasive recording systems such as EEG to collect your signals. And then one important step that we do is applying machine learning or deep learning to these signals to understand what goes on in the brain, the kind of intentions or thoughts people hold. And then we use the outcome of this modeling approaches for control of external devices. And traditionally, these external devices used to be assistive technologies like medically approved technologies such as wheelchairs or bionic arms. But these days, we also use this for control of serious games, social robots, or virtual environments. Is there a technical problem?
No, we are
Good?
solving.
Yeah, is it good? I thought that you were
Yeah,
struggling with
continue.
something. Yeah, okay, then I continue. So then one important element after you establish such control through your brain signals with the environment is feedback. And that's the kind of reaction or response you get from these devices that are controlled with your brain signals. And they actually can help the user to learn, to interact with the system better, to modulate their brain signals better. And generally, it helps them to achieve that neuro adaptive interaction that we envision for them. And then for my PhD research, I actually started having this thought of integrating these BCI systems in the control of the Android robots. So the whole laboratory that I was working on, which was focused on intelligent robots, looked into how humans operate this very human-like entities and what kind of phenomena they experience. So most of the research that was conducted there was at the intersection of psychology, neuroscience, cognitive science, as well as engineering. And one important phenomena that we were looking at was the embodiment illusion. This embodiment illusion occurs for almost everybody, and you might have heard of it in the form of rubber hand illusion. That is when your brain is tricked into believing that another object that looks like a human body and is sort of providing you sensory stimuli that are very similar to your real body, that can be part of you. So you sort of consider it as a self body. And this is an illusion that your brain holds, and it tricks you into incorporating that non-body object into your body schema. So at the time, there were a number of research that had already looked into this brain illusion under different mechanisms. And no one had ever thought of looking into BCI facilitated embodiment illusions. And the way I tried to confirm this illusion in my experiment was to enable human users to control a robot body with only the power of their brain signals. You can see an example of my research setup in this slide. So on one hand, I had users that were equipped with these EEG electrodes. These are electrodes that collect brain signals from the scalp of your brain. It takes about 15 to 25 minutes to prepare the subject with these EEG electrodes. And then once they wear this electrode cap, we can collect their brain signals, we can pass it to controllers, and then we can pass it to classifiers and then the controllers, and their thought of movement can then be translated into the movement command for the robots that they are operating. In this case, the robot that you see on the left side was located in another room. So we were sort of enabling the user to teleoperate the robot. Every time they thought about a right or left hand movement, the brain activation patterns changed, and we used this neural pattern change to understand which side of the body they were imagining a movement for. So it could be a right hand or a left hand. And as soon as they had that imagination, that mental intention, the robot would act on it based on the brain signal. So if they imagine to grasp a ball that was in the right hand of the robot would implement that action. And then they continued this act. So for a number of times, they saw this lighted ball either in the right or left hand. And every time it lighted, they were instructed to think of a movement that would lead to the robot's action. And then what we did is that after a while, we threatened the robot hand with a painful stimuli. We don't have a picture here, but it was an injection we applied to the robot hand. And we would look at the user response toward this threatening stimuli. If they showed a stress reaction, then we would know that their brain experienced that illusion of considering the robot body as part of their body. So with this whole experiment, I could actually first confirm that the embodiment illusion is possible through BCI operated robots. So if you control a robot body only with the power of your brains without moving your real body, it is still possible to trick your brain into believing that robot body is yours. And more importantly, the second part of my research was about how this feeling of embodiment is going to impact your power to modulate your brain signals. We saw that people, through multiple experiments that we conducted, we saw that people that were able to that were able to experience this embodiment illusion, they were also better controllers of the robot. They were able to act on these imaginations and create the neural patterns that we wanted in our classifier better. So we sort of related this embodiment illusion to the neurofeedback performance of the user. And even today, I'm still using this concept of embodiment and feedback design in generating better brain-computer interfacing interactions. Then after I finished my PhD, which was mostly focused on embodiment and BCI control, I started working on neuroadaptive human-robot interaction. So rather than focusing on active engagement of the user in a BCI task, this time my project was about passive monitoring of brain signals when users were supposed to learn from a robot or conduct a therapeutic intervention with a robot. So until then, most of the human-robot interaction studies could only evaluate user through subjective surveys or behavioral analysis. So after the users did a task or interacted, conversed with a robot, people would give them a questionnaire and say, okay, how did you feel about this experience? Or the researchers videotaped the user, and then later they spent hours of video coding in order to understand what kind of postures or facial expressions they showed. So of course, this was quite laborious and very hard to implement in real time. And that's when I actually suggested in a paper that I published in Frontiers in Robotics and AI that we can use neurophysiological signals, such as brain signals, in order to bring in real-time detection of cognitive and affective states into that interaction scenario. So as you can see here, there is a loop that is very similar to the BCI loop I showed you at the beginning. First, during the interaction, you can collect brain signals from the user when they are engaged in a task with the social robot. Then we apply machine learning and signal processing techniques in order to extract mental states of the user. And in the controller stage, we pass this to the robot decision-making models, and the robot would then neuroadaptively change its behavior in order to provide a personalized response or reaction to the user's need. And this is what we call a neuroadaptive human-robot interaction. We conducted a series of experiments. Here you can see multiple images of the experiments we conducted where our users were equipped with the EEG sensors, and then the robot would monitor their brain signals as they were interacting with them. Most of these studies were focused on learning, as I said before. And the idea here was that whether it's possible to extract engagement and attention levels as users were learning from the robot. So, for example, on top right, you see an example where children are learning from a robot tutor. On the left top side, you see an example of a human adult user learning a new language, a fake language from the robot. And then the collection of these studies, what we learned from was that when you implement neuroadaptive interaction, it's actually possible to keep your user more engaged, to help them maintain their attention levels better. And in fact, the learning performance, the learning gain of the user also improved. So in one experiment, we had, for example, two conditions. When the robot neuroadaptively provided feedback. In the other condition, the robot provided the same feedback, but in a random timing. And then we realized that in the neuroadaptive condition, people were more engaged in the task, and they also recalled more information from the learning material. So that all was promising because it showed us that the same thing people were trying to do at the time with behavioral analysis now can be done with neurophysiological data, which is more dynamic and in terms of real timeness, more accurate. And more importantly, it's also more cost effective. So it takes much less computational power to look into brain signals in real time compared to when you want to process a lot of video frames. And then after this, when I moved to the Netherlands, I started applying similar concepts to virtual worlds and immersive interaction. So here you see examples of the research my students did when users were immersed in virtual environments. The task they were engaged in was again a learning or creative ideation task. And the idea behind our project was to monitor mental states in real time so that we can enhance the user experience. On the top of the slide, you see an image from an experiment we conducted where people were supposed to come up with as many as ideas they can think of in relation to a problem-solving task. And they did it either in a virtual reality environment or a 2D screen-based environment. And when we looked into their brain signals, we saw more prominent activation patterns associated with creativity mind states. So this was an indicator for us that virtual environments, 3D environments, which are visually richer, can actually stimulate the human brain when the user is focused on problem-solving tasks. It probably provides a more input to process at the time. What you see on the bottom left is an image of a experiment of actually a whole project we did together with Air Force pilots when they maneuvered a simulated aircraft, and then we looked into their brain signals in order to extract workload, neural markers of workload. And workload is a very important factor in aviation training, in flight training, because pilots, if they are overloaded with sensory information, they experience a phenomenon called inattentional deafness. It means that they are so overloaded cognitively that they no longer can hear any alarm in the cockpit or in the in the simulator. And this is very risky. This is very dangerous because it can lead to fatal accidents. So in most cases in their training, they are actually they go through these scenarios of excessive workload. And what we actually wanted to do for this was to create simulations that can provide this form of, that can modulate this level of workload during the training for the pilots in a personalized manner. So one of the experiments we did was that the pilots would receive a harder maneuver if their workload was below a certain threshold, or the other way around, if the system, our BCI system, detected that the pilot is experiencing excessive workload, then the next trial, the next training provided a simpler maneuver. So in a way, we personalized the training program, and then we looked at how performance and the learning curve of the pilots changed. And one final experiment that my students did was more focused on gamification of neurofeedback training. We know from research that it's very hard to modulate your brain signals. So BCIs, the way they are portrayed in media, they are the next hype technology, right? So they're going to be around the corner. You're going to be able to control your environment, your car with your brain signal. But is that really true? Are we that far already in terms of technology development? The answer to that is no. We still need to work on our hardware development. We need to work on software development to be able to extract multiple mental states that are relevant for our daily activity. And importantly, there is a huge individual difference. My brain activity being different from yours, and the model that is trained to work with my brain signals can probably not work with your brain signals. So those are some of the challenges we are experiencing. And therefore, in order for a user to be able to use a BCI system, they need to be first trained. They need to learn how the system works, and the system also needs to learn how the brain signals of this user looks like. And oftentimes, this training can be very tedious for the user until the system is accurately calibrated. And in one of our experiments, we actually focus on gamification of this process. And we learned that through gamification of BCI interaction, we can actually ease the BCI task learning for the user, and we can improve the performance and accuracy of the system. So that all together summarizes what I have been working on. In the second part of this talk, I actually want to tell you to basically disclose some of the personal reasons that inspired me to do a PhD at the time. And I guess this part of the talk can be more useful for students that are in later stages of their master's program, or people in business sectors, industry sectors that are still thinking about coming back to academia. I think one of the reasons that was really important for me when I chose this path for myself, the academic path for myself, was that I very much valued my freedom and autonomy in learning new things as a goal of my career. So I actually wanted to continue learning, and I thought that just showing up to work at 9 and finishing it at 5, being like, probably wouldn't have been the case for me, but it's still like trying to continue repeatedly a monotonous task would not be something for me. I wanted to be challenged in my work every day, and I also wanted to manage my time as flexibly as possible. So that's why I decided that I want to become a researcher, knowing that oftentimes scientists do not work early morning hours, but late hours, and I'm not a morning person. So that also justified the choice. Then the next thing I already said was my passion for learning. And beyond learning, I also have realized that I have a passion for mentoring and nurturing the next generation of researchers. It's a very fulfilling and rewarding part of my work. I really love being a university professor, specifically for this part, because of my interactions with the students. It keeps me young, first and foremost, because they are full of energy, full of life, and they most often they are so motivated to learn, and their enthusiasm is contagious. It makes me also enthusiastic about my research, and I also think that I'm good at it. So the kind of um, skills transfer and experience transfer that I establish with my students, it has shown me over time that it can actually lead to very successful project completions. I know some of my colleagues who are really good researcher, very good thinkers, but somehow maybe not the best educator. But I think this is something that I enjoy and I appreciate as part of my work. And because I'm good at it, I also feel like this was the right path for me. And then last thing is that at the time when I choose to do a PhD, I thought that I really want to do something that stays for me. So it's something that will be left as a legacy behind, as the work that this person, Maryam, did in her life that could be useful and practical for others that come along. And I think, for example, my PhD thesis, the projects I do together with my students, the publications we make, they can be that form of legacy I was looking for. But of course, this whole journey was not without challenges. If somebody tells you it's easy, they're probably lying or they're super, super smart. Uh, Doing a PhD can actually can expose you to a lot of mental challenges as well as academic challenges. So that's what I would like to talk about here. These challenges that I faced, and I also see my student facing in their PhD project, are categorized into these two categories, academic challenges and mental challenges. I would like to first start with the academic challenges. What are you going to expect? What should you expect if you step into this path? The first thing is that choosing your topic and supervisor can be a bit challenging, especially with the fast advancement of science. Particularly in my domain, I work in the domain of AI, and there is no day that we don't have a new publication and new advancement. So the domain is moving so fast, and you need to be very sharp and on top of everything to be able to choose the right topic, and then also the right research team to work with. So this choice is a quite a challenging choice. The next thing is related. There is too much to learn, and sometimes you feel like you are left behind. And no matter how hard you try, you cannot keep up with all these smart people that are around you. And of course, my recommendation for any student that is struggling with that, even as part of their undergrad or master studies, is to give yourself time. You need to take it one step at a time. And of course, there is no person in this world that is the expert of everything. We all develop the expertise over time, and we only have the expertise within a very niche domain. So allow yourself time to get adapted and to learn what you're supposed to learn. Also, choose your learning path very wisely. Choose what you're passionate about so that you can overcome the challenges there. Then there is also cross-discipline challenges. I think it's very hard to say that these days we have exact sciences. You can no longer separate engineering from psychology, from neuroscience, from cognitive science. It's just not possible. Everything is so intertwined, and this was something that I also experienced in my PhD research. I needed to know a bit of everything to be able to set up my proposal and my experiments. And this, of course, taps into the same topic I discussed before. There is too much to learn. So if you're already so advanced in this domain, we also need to gather and absorb all the knowledge before we can find the right gap, the unknowns to focus on. So that can be an academically challenging thing for a newcomer, a new PhD researcher. Then there is workload and publication pressure. I don't know what sectors the audience are working at. I can imagine in every sector, in every industry domain, there is workload and there is pressure from peers. But from what I have experienced in academia, it's particularly harsh because we do not have very let's say, specified timeline for our work. It actually is a side effect of the freedom I was talking about before. So it's not like every morning at 9 o'clock somebody is checking whether I'm in office or not. But it's also the case that sometimes I have to work until 12 midnight in order to make it to a deadline, a conference publication or journal publication. And journal publication is the indicator of our performance. So this publication pressure is something that every researcher deals with. No matter how knowledgeable you are, how good you are at your stuff, if you don't publish it, if there is no peer review process that validates your findings, then what you have found and what you have learned is essentially worthless. So this whole publication pressure is now improving, I would say, in academic environment by enabling researchers to share preprints of their work. For some domains, conference publication is becoming as impactful as journal publications, but the whole concept is still stays there. So if you are stepping into this world, please know that you need to prove yourself. And the peers can be quite tough in that regard. So yeah, that's part of the challenge that you have to face. And then one last thing is that compared to other careers, an academic career can go very slow in terms of outcomes. Um, I just talked about publication, and that's a good example because from the moment you have an idea and you conduct an experiment, you analyze your data, you write it up, you submit it to a journal, you receive the first round of feedback, you implement it, pass it again. It takes 3 months for the reviewers to look at it. They give you the second round of feedback, you implement it, and finally your paper gets accepted and published. That can easily be 2 years. 1 or 2 years. So as you can see, there takes like a very long time before what you had thought as an idea for your research becomes solidified as a published paper. And this slowness of the process can demotivate some people in the midway. Staying motivated is really hard, and I think the only factor that can contribute for you to stay motivated here is that you are passionate about your topic. Hence, the first item I put on this list, choosing your topic and the team you work with, the supervisor you work with, is really important. Then I would like to talk about the second category of the challenges that probably are not academic specific, but are more prevalent in the academic environment. I call these the mental challenges, and the first one is the work-life balance. Yeah, I talked about workload and the pressure of publication. So if you need to work very flexibly, to work long hours before a deadline, and it takes very long time before things can turn into an actual deliverable that you can look at and say, well, I did the work. Then your work-life balance is quite at risk. And there would be Saturdays and Sundays that although you gave yourself a rest and you did not, you thought that I'm not going to open my computer and work today, you are still mentally engaged in some of the things that are still in the pipeline, right? So it's really hard for us, the scientists and academicians, to switch off. And some of us are really good at doing that because they train for it. But otherwise, if you do not really focus on your work-life balance, it's not something that is given to you. Then the relationship with supervisors and colleagues can sometimes sour, and this is something that can affect a lot of PhD students. My recommendation for everybody who wants to choose a career, especially an academic career, is to do very thorough research before you choose the team that you're working with. If the relationship with colleagues and supervisors is not going well, it will be very hard for you to stay focused on the content. And academic work is all about concentration and thinking. So if you are obsessively thinking about other stuff that are noise, it will be very hard to be productive. And then stress management. Yeah, that's something that, again, probably is not university specific. Everybody in their work deals with stress, but maybe because there is more risk of work-life imbalance or competitive environment around you, this stress is more prominent among the students. I think it's really important that for this, you have a very good support system around you, family members, partners, friends that can help you through difficult times, that can support you when, for example, you're rejected by the peers. And generally, it really helps if you work on the softer skills that enable you to manage your stress better. The competition and rejection, this is related to publication pressure and the expectation, the very, I would say, unreasonable expectation that we have of ourselves in academic environment as well as some of our colleagues. So the thing is that when you work at the university, you are generally working with some of the smartest people you ever see in your life. The more you go up, the higher levels you go, the better and smarter these people become, because these are the people who are reaching the higher ranks. And of course, this feeling of competition and the fact that you're not enough kind of grows. And it also becomes very hard to mentally deal with these feelings. As PhD researcher, because you are at the beginning of your career, and you see all these people around you, you also see other PhD students who sometimes are performing better just because of a timely acceptance of their publication. This, I have seen, can also count as a mental challenge for them. And then this relates well to the final point I wanted to make, which is about perfectionism and imposter syndrome. Imposter syndrome, as the psychology word defines it, refers to this lack of confidence in what a person knows. And we know from psychology research, there's actually a terminology that defines this effect. It's called the Dunning-Kruger effect. The researchers that look into this effect, it shows a relationship that people have in terms of their confidence of a topic and their actual knowledge and skills in that topic or in that field. And normally, how humans operate is that as soon as they know a bit about a topic, they suddenly feel that, okay, I know enough. They feel confident in actually pitching their ideas about the topic and engaging in these deep discussions about it. But it's only after you know more that you realize, oh, there seems to be much deeper information and debate around this topic that I still need to engage in. And this is quite the case for PhD research, because PhD research, unlike master's studies and bachelor's studies, is about advancing research, is about advancing knowledge. It's not about just reading through existing material and learning it. You actually have to produce knowledge. So then you start seeing all the contradictory and inconsistent information. You need to ask questions that nobody tried to answer before. And that's when you start seeing a decrease in your confidence of the topic, and you fall into this valley of lack of confidence. And that's what we know as the imposter syndrome. The fact that you are surrounded by people that all seem like an expert. They seem to know the field very well, and down deep, you think that you don't know enough. What we know is that if you hang in there enough, if you get through this phase, after a few years of mastering the topic, you eventually grow back increase your confidence again in the topic. And that's when normally when some of the senior established researcher sort of grow into this guru figure, expert figure in the field. So that's what I can say about this. This is not avoidable. This is something you just need to be aware of and deal with until you hit that level, that balanced level of confidence and knowledge. Okay, so here is my last slide that I would like to share with you. If you are going for a PhD program, if you're a student and are considering it, or if you are a business person that are thinking about coming back to academia, please first make sure that you know why you're doing this. I know that in some countries, holding a university degree can come as a very credible ranking indicator. I would suggest that you don't do it for credentials, but you do it for your passion of learning, for your curiosity. And this is really important because it's long, it's challenging, and that sort of like the facade of like, okay, this is my status, that can actually disappear after a few months. So yeah, you need to stay passionate about the topic. Otherwise, it can actually lead to quitting the program or risking your mental health. Then the second advice I have for you is to choose your topic and supervisor very carefully. The topic should be something that you are familiar with, but you can also learn more about. It should also be something that excites you, not just because it's the hyped topic of the day, you need to go for it. I know, for example, now AI and data science is something that all the students want to do because there is career prospects. But is that what you really want? I do have students enrolled in data science program, but it's really hard for them to code. It's not something that they are meant for. So please consider whether the topic that you choose is something for you or is it more for your CV. And then look for a supportive and communicative mentor as your supervisor. As I just said, we know that there are many, many good researchers and scientists, very highly known, very successful in grant acquisition. Like the whole university knows their name, but are they the person that are also supportive of you in the process? Normally, big names are also quite busy. So maybe they cannot dedicate all the time that you need as a PhD student to receive mentoring and guidance. Make sure that there is a click between you and your supervisor. And based on your research, you know that this is a supervisor that would support you through the process. At the end of 3-4 years of your PhD, you don't say, well, I was most of the time alone and I did this all the way on my own. And then the other suggestion I have for you is to work on your soft skills. This is mostly related to the mental challenges, and I think soft skills can really help you get through those mental challenges throughout a PhD journey. Stress management skills, time management skills can really help you to be productive and effective. And I think communication skills is also a very important one. So the formal language of science is English. And I know that for some international students, developing these communication skills could be very challenging. If you're considering to do your PhD, even if it's in your home country, and you do all the communication with your supervisor in your own native language, you need to make sure that you can present and sell your research outside of your comfort zone internationally to the international researchers. So both the speaking and writing communication skills are very important that you need to work on early on. And last but not least, please know that this was all reflections of a person who remained in academia after their PhD. So I only know how it goes in universities and in knowledge institutions. But of course, if you get a PhD, choosing an academic career is not the only option and door open to you. These days, you have the opportunity to work for big techs. Your degree is no longer considered as like the what do they call it? The overqualification, right? It used to be the case that if you wanted to work for a company, they didn't really necessarily have interest in PhDs, but today we do. Now people, the technology companies are looking for people who know problem solving, and that's what you actually learn through your PhD program. So I just want to say that the doors remain open for you, and academic environment is actually an environment that can train you and educate you to become a highly professional expert in a career domain that is outside of university and academia. Thank you so much. I'm happy to take your questions if you're interested in PhD or if you have any questions about my research that I pitched earlier.
Perfect. So thank you, Maryam, again for the excellent talk. We have some questions, so I will switch to Slido now, if it's okay.
Yeah, I stopped sharing.
Okay, perfect. I will find it. Too many windows, you know. Probably this one is the right one. And now I will share it. Here, hopefully also the participants. Wait. So to read them, I have to go through all of that part that we skipped at the beginning because the focus is on your talk. So quiz and all the stuff we skipped. And now they can also rate your talk. Now that I then yeah, nice. You have 10 also for me.
This is quite stressful. You watch how people evaluate on the spot.
It was really excellent, and I at least hope that also others will appreciate your tips also how to prioritize in order to pick the PhD. And you didn't mention yet that you are also opening the positions at your university in Amsterdam.
Yeah, but that position that we opened, unfortunately, it closed 4 days ago. So you cannot apply any longer, but there are more coming up. So after summer, we will have another project for which we are hiring, and I will announce it via LinkedIn for sure.
Okay, perfect. So they should check you also on LinkedIn.
Yes, and of
And
course, check our university vacancy page. So the university has a vacancy page, and all the openings from every department goes on that page.
Okay, so I will thank you for that. I will read the questions because so far Lukáš left and he was putting the right slides on the panel behind me, but I will read it. So we have one question from Marek. How long does it usually take to train a brain-computer interface system using games? And does using games different motivation instead of normal training improve the training results?
Yes, thank you for this question. This is already an exciting start. So it really depends on the BCI paradigm and what we are extracting from the brain signals for that particular BCI interaction. So there are some BCIs that look into mental imagination of certain movements. These are what we call active or motor imagery BCIs. There are some BCIs that look into your brain responses to certain visual or auditory stimuli. These are what we call reactive or event-related potential BCIs. And there is one last category of BCIs that basically monitor your brain signals over a sliding window. So it's not about a certain response that your brain shows at a certain moment, but it's more about how generally your brain signals are changing in the time domain or frequency domain over time. And each of these systems can take a different training and calibration time. I think with reactive and active BCI, that is usually around 5 to 6 minutes of time that you need to provide data associated with the task that you need to do together with the system before you can actually use it for that task. So the system needs to give you around 40-50 examples of the same task, collect your brain signals in response to that task, and then we apply some training step where we update the parameters of our model based on the brain signals we collected. And then after that, you can start using the system. Now, whether we can improve this through gamification, the answer is yes. We actually do have evidence for this in a very recent study that I did together with my students. What gamification does is that it helps users to stay more engaged in the process. It's a very tedious and long process to repeat the same task until the model has seen enough data for that task. By gamifying, we're actually diversifying the way that the user engages in this interaction, in this training moment for the system. And then through higher engagement, they also become more attentive and they achieve better performance in the calibration run. I hope I answered the question fully. Please let me know if you have follow-up.
Definitely. Thank you for that. There is another question from Kay. I didn't know that it is possible to work on PhD project as a team. How did you find the team and choose the project?
Yeah, it really depends on the country where you're doing your PhD project. For example, when I was in Japan, and I think it's very similar in the US, doing a PhD counts as being a student. So you actually are registered in a university and you pay tuition fee. And then you can freely choose the topic you want to work on. And you can work on it individually or sometimes together with another researcher in the same laboratory. But in Europe, where PhD positions are sort of funded employment, the project finances your position, and basically projects have a predefined proposal and research goal toward which you must work. Of course, there is flexibility for students to draft their proposal and deviate a bit from the general goals of that project. But oftentimes that project, because it's externally funded, it needs to also deliver some deliverables, and the PhD student needs to work on that. In such projects, it is usually the case that there are more than one PhD working on the project. So the project addresses a number of research questions, and each PhD student works on one research question at a time. And then the PI of the project, the principal investigator of the project, brings everything together as the result of the project. So in such teams, in such consortiums, you actually need to know what others are working on, how your research relates to them, and sometimes you need to do joint experiments and studies with them. For example, you produce data that they use in their AI modeling, or the other way around. And so it is the case that, yeah, for such larger scale collaboration, you need to be socially skilled to work together with others. And how you find this position, it really depends on the opening. So we like the same position that you were referring to, Radovan. So we had financing, and it's a funded project where multiple PhD students are hired in different universities in the Netherlands, and somehow, although each of them work on a specific sub-project within the larger project, all these sub-projects are interconnected. So the answer is just try to find them and apply online.
Okay, perfect. Thank you for the answer. By Kate, there is another question. Did you feel pressure or higher demands on you as a woman in tech segment?
This is the controversial question. I am not honest if I say no. Yes, I did feel it. And I think the pressure was higher when I was actually in Japan. So it's not hidden from everyone that Asian countries, especially Japan, are quite male dominated. And it also has to do something with the domain. So the tech domain, the AI domain, the robotics domain, less females engage in this domain. So I was actually a double minority when I was doing my PhD in Japan. I was a foreigner, so I was an international student among a lot of Japanese colleagues, and I was also a female. So most of my colleagues were male Japanese, and I was like a female international. That kind of like that was hard to navigate through culturally. But I think one thing that came to my advantage was that I was already there in Japan from a very young age. And although my face did not look as one of them, I knew how to behave so that I'm integrated enough in the lab culture. And I tried, I really tried. But the reason that I decided that I actually want to join a faculty outside of Japan was exactly for this, that I saw a very low glass ceiling. And I decided that I want to move to a place where women have more opportunities. And I think in the Netherlands, it's much better. I think based on the statistics, there is still a gap between female and male faculty members, but I think generally I'm more satisfied here.
Okay, perfect. So another question from Slido is that it's anonymous question, and you mentioned that you love teaching and mentoring. Have you considered also or to do teach some MOOC or big online course in the near future? You can basically probably
Yeah.
what they are
So this
asking,
is,
you can
yeah,
reach more people than in academia.
yeah, so this is not something we do individually because it can take quite a lot of time from us, and we're already quite swamped with the educational duties we have at university. But there are some projects within the university that tries to develop such MOOC programs. And then what they do is that it's not just one individual lecturer that engages in, it's a collection of lecturers and professors that come together and put together material. So I think the VU, the university I am with, does have such initiatives.
Okay, perfect. Another question is, will the slides be available after talk? Yes, they will be. And hopefully also your slides you can share.
Yeah, I can share that, of course.
And another question is, do you think that it will be possible to implement like functional Neuralink in the near future, like to put it into our hardware and that it works like in metrics? You download basically like
Okay,
yeah.
okay, there are two parts to this question. The first part, whether we will have functional implantables. Yes, we already do, and they are mostly used in the clinical the application domains. But I think once they are ethically, legally, and yeah, clinically cleared, they will be also available for healthy people who want to consider it. The second part, whether you can start downloading or uploading skills into the brain, that I think a very futuristic goal that we are moving toward too, but I don't have a good answer for that in with respect to the timeline. I don't think it's something that we can see within 1 or 2 decades.
Okay, so perfect. So for the future, maybe.
Yeah.
And the last question is by me. Would you also come in person as a speaker or keynote speaker in future PyData Slovakia conference in Bratislava or Košice, where we met for the first time?
Yes, of course. Why not? It would be my pleasure.
Okay, perfect. So
Yeah.
we will
Thank you
keep
so
that,
much,
keep that
Radovan.
in mind. We will
Yes.
keep that in mind, and we need to
Yes.
like just find the budget all to
Yes.
cover it all.
Yeah, let's stay in touch. Actually, my next meeting, people are already calling me. So is it okay if
Yeah,
we
yeah,
wrap
yeah.
up here and I
Thank
step
you.
out of this
Yeah,
room?
yeah, yeah. Thank you for your time and for your availability, and
May
also
I choose the question, the best question?
yeah, the best
Yeah,
question.
I think the first question you asked with respect to the training of the BCIs and how much time it takes and
Yeah,
how the
by Marek.
communication helps. Yeah, that was,
So he
I
will
think
be
that was the most informed question.
perfect. So
Yeah.
thank you for that. He will get this AI engineering book by
Nice.
Cheap
Okay.
UA. So that one.
Thank you so much. And thank you for inviting me, both for today and perhaps in the future in person.
Definitely,
Yeah.
definitely.
Yeah.
So
Thank you
let's
so
stay in touch.
much and have a nice day and weekend, everyone.
Thank you, Maryam.
Yeah. Bye-bye.
Okay, so I will now just finish the webinar also, and also this meeting. I would like to share also more info about NumFocus and also about our upcoming partnership that we would like to announce today. It will be from June. There will be new partnership with Lenovo. Lenovo has one of the biggest like offices here within Europe, here in Bratislava, and we will coordinate also with their Sweden office, and they will provide extra hardware for our meetups, mostly from the level of, as you probably know, Lenovo bought all the hardware from IBM. And this hardware includes also the like workstation level of notebooks and other stuff. So they will provide that in partnership with us. Next in-person meetup will be at the end of October, but we will now switch to webinars in June. And we would like to again thanks to our sponsors. Best question had Marek, and also was picked uh, by Maryam. So here is the main prize, and this is also for you and for your friend or whoever you can share, or colleague from company or whatever. And there are still the dev stickers, so feel free to like take some. I would just like to thank also our online participants and also those who came in person here to Svizre. And see you next time in person at the end of October, as I mentioned. And that's it from my side. So thanks again, and see you next time via webinars or in person.